Okay, so let's talk about exponential decay. In exponential decay, the original amount decreases by the same percent over a period of time. A variation of the growth equation can be used as the general equation for exponential decay. So here, whatever the percent of decrease is, you're going to subtract that from 1 right here. See how that's subtraction? It's just like the equation for exponential growth, except instead of adding the rate of change, you're going to subtract the rate of change because that's the percent that it's going down. Okay, and then what's going to happen is the 1 minus r is going to be a number less than 1, still positive, but less than 1. And we know that that represents exponential decay from our previous section. So a fully inflated child's raft for a pool is losing, keyword, losing, which implies decrease or decay, 6% of its air every day. The raft originally contained 4,500 cubic inches of air. So let's write an equation that represents the loss of air. I know that the initial amount is 4,500 cubic inches. I know that the rate is 6.6%, but I also know that I have to put that in as a decimal, okay? So here's the original equation for exponential decay. A is 4,500 and 6.6% as a decimal, you'll move it over twice, is 0.066. Okay, so now here's where you have to be careful. You do 1 minus that number, all right, which is 0.934. Now what the 0.934 ends up meaning is that after each day, it has 93.4% of the air left in it that was in it the day before. Okay, so if it's losing 6.6%, then 93.4% is left, okay? But 93.4%, even though that would be an A on a test, is less than 100%, which means the amount is going down by 6.6%, okay? So that's the equation where Y is the air in the raft in cubic inches after T days. So if I want the amount in the raft after 7 days, just plug 7 in for T, follow your order of operations, or enter it exactly like you see it into your calculator, and you would get 2,790 if you round it to the nearest amount of, or the nearest whole number. So that represents that the amount of air left in the raft after 7 days will be about 2,790 cubic inches. Okay, here's one for you to try. Go ahead and pause the video when you're ready. I mean, hit play when you're ready. All right, the population of Campbell County, Kentucky has been decreasing. Important word there, decreasing, because when you see the word decreasing, you should automatically think going down. That means I'm talking about exponential decay at an average rate of about 0.3% per year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. And if the trend continues, predict the population in 2010. So I know the initial amount of people in 2000 was 88,647. And I know that R is 0.3%. Now be careful, even though there's a decimal in the percentage, it's still given with the percent symbol, which means it's still a percent. We have to move it 2 decimal places to the left to get our R value. So R is 0.003. So you have Y equals A times 1 minus R to the T. So you would have 88,647 times 1 minus 0.003 to the T, which is 88,000. That looks like a Z. That's an equal symbol. 88,647 times. Now if you subtract that off, you get 0.997. Notice that that number that's raised, that the base of the exponent is, the 0.997 is less than 1. It's a little bit less, but it's still less than 1. So that means you're talking about decrease. If the problem is exponential decay, then when you get this number in the parentheses here, it should be less than 1. Okay? Now, all we have to do to get the population in 2010 is not put in 2010, because remember, T represents the number of years since, right here, since 2000. So y is equal to 88,647 times 0.997. In 2010, that's 10 years after 2000, so you plug in a 10. You get 88,647, parentheses, 0.997, parentheses, raised to the 10th power. Right. Yep, there we go. And it's 86,023 people. Okay. Now, does our answer make sense? Yes, because we started off with more than we ended up with. It's only 10 years, so it's not a whole lot of time. And we're only going down by 0.3% per year. So the rate of decrease is not very much. Okay. So you have two things that kind of come into play. The amount that the percentage that it goes up and down and how long it's been doing it for. Okay. So if you have a growth problem and your answer is smaller than what you started with, you know you did something wrong. If you have a decay problem and your answer is bigger than what you started with, you know you did something wrong. Okay. All right, guys, that's it for this section. Please continue on to your assignment. And as always, reach out to me if you have any questions. You take care, and we'll talk to you later.